네, 안녕하세요. 저희는 병렬컴퓨팅을 통한 컴퓨터 처리속도 향상에 관한 연구에 대해 발표할 조이엔, 최성우, 박준서입니다. 네, 지금부터 저희의 발표는 영어로 진행되겠습니다. As the first industrial revolution and IT era, the big data and artificial intelligence is increasing. GPU is the center of this development. NVIDIA CEO Jensen Huang emphasized the importance of GPU in the NVIDIA forum. He said, "The times of GPU has come. GPU is expected to grow rapidly with artificial intelligence. The special framework, unlike CPU, led to GPU's growth. This green schematic the structure of CPU and GPU. Green part is ALU, the primary operating system. As you see, GPU has it much more than CPU. So, when you process a large amount of data, GPU is faster than CPU. And then, parallel computing is made it possible. Parallel computing is a technique which calculates its parts in a several operating system and then finishes in a single program. So we focus on this technique and set up the three categories for our study. The first is repetition sentence, the second is conditional sentence, the last is sort algorithm. And there is two subcategories for each. We will design function and compare the computation processing speed of CPU and GPU across each category, and repeat the same experiment 3 times to increase accuracy of data.
Then, I will tell you about the architecture CUDA and its terms. The CUDA is an expanded edition of C language to use GPU processing. The first type of term is kernel. The kernel is a function that executed in GPU. The second type of term is CUDA memory allocation and CUDA memory copy. The CUDA memory allocation and CUDA memory copy is important because the type of GPU variables are defined by pointer. So, these functions are important in GPU computing. The next is thread index and block index. These thread index and block index are also important because it is necessary for computing each part.
Our first experiment is about repetition sentence. Let's see the result of 4 sentences. The blue one is GPU and the red one is CPU. In 15 to the power of 5 times calculation, GPU was faster about 24 seconds than CPU. As you can see, GPU's performance is better than CPU. Next is the while sentence. In 15 to the power of 5 times calculation, GPU was faster about 26 seconds than CPU. Our second experiment is about conditional sentence. In this experiment, unlike the result of repetition sentence, CPU was better than GPU. Here is the result of if sentence. As you can see, CPU's performance is better than GPU. Next is the conditional operator. Like if sentence, CPU was better than GPU. Our last experiment is about sort algorithm. Let's see the result of insertion sort. Because of this algorithm's characteristic, there were no differences between CPU and GPU. However, bubble sort showed us impressive result. When we sorted 500,000 data, GPU was faster about 4 minutes than CPU.
As data As data encode become larger, the processing speed of GPU is faster than that of CPU. But in case of conditional sentence, the usage of ALU in GPU is become double when condition is divergent. So bubble sort algorithm is effective than insert sort algorithm. The limit of GPU is, as mentioned before, the conditional sentence. It's because the usage of ALU in GPU become double and triple when program pass the diverge of conditional sentence. So in this situation, GPU overload can be occurred. So the whole processing ability of GPU is inferior than that of CPU. We can recover these problems by combination of CPU code and GPU code. The repetition code is in GPU code. The conditional code is in CPU code. This is the application of this problem. At first, the GPU was made for only graphical operation, but now GPU has prime role in AI, cloud computing, and fast processing. These parts are important in the first industrial revolution. So I hope our research will helpful in first industrial revolution. Thank you for watching.